This isn't a how-to since I've only made one working underpowered motor so far. It's more of a documentation since there's going to be a lot of things done wrong, and if you have suggestions, please let me know. Starting out with the casing, we're using 1.5 inch OD DOM tubing. This is easy to source locally, but it's pretty heavy and not really good for flight. Even with elevated temperatures, this thing will burst at about 6,000 PSI. Well, so I expect. This is commonly referred to as a boilerplate motor since it's many times more, in this case 8x, the max operating pressure, or MEOP. This is not very safe since if it goes, that is a lot of energy. In order to mitigate this, we're going to be using shear bolts. In our case, 3 1/4 inch by 20, just standard bolts like grade 2. This should blow off at about 2,000 PSI or so and leave plenty of headroom between the shear bolts going and the whole thing exploding. It should fail in bearing failure as seen here, and we'll see what happens. Okay, now that we got the casing and shear bolts sorted out, we move to Richard Naka's solid rocket motor design software. This thing is sweet. Put in the parameters, get your results, get your nozzle data, you name it. I'm going to be using KNER fuel this time instead of the usual sorbitol like I did last time, since it does not absorb water, supposedly. This will take out the humidity variable in the fuel and make planning easier in the future. We're down 5 grains, about 3 inches each, give us a nice, somewhat flat cam profile, peaking out at 597. Above this can, you get kind of diminishing returns with just more pressure. So, moving on, this will give us an 8mm throat diameter. This is about 5/16 drill bit, which is nice, so I'll be using that. And it is a large throat diameter to chamber length ratio. You normally wouldn't want to do this, keep it under 35, otherwise you get erosive burning. However, KNER fuel burns slower than the sorbitol and other sugar fuels, and I'm going to be using a larger core towards the bottom, a 5/8 instead of 1/2 inch, so hopefully that will diminish those effects. If this all goes well, we got an output of like the i329 motor, or 629 Newton seconds total impulse to be burned for about 2 seconds. We'll see what happens. Pack it in, this will be like our filter kinda. Bam. Oh man, is that a B? Oh lordy. It is currently 10:45 p.m., so hopefully it goes smoothly. Where should we put this in? Okay. What do you mean get it? Yeah. What are we looking at?
371.
What's the case? 246. So why the loss in power? I think mainly it's due to the long ignition time, especially for KNER fuel. It is not like to burn under atmospheric pressure. So you need an igniter to get it up to those operating pressures. Usually, the size of the igniter is decided based on your chamber volume, but I ended up going with a much smaller igniter since I painted on an ignition powder, hoping this would make up for it, but clearly it didn't work. There could also be some residual grease left over from the coring rods. Maybe do a better job cleaning it next time. And I also ignored the ignition powder when deciding on igniter size. You also may have noticed that the max pressure / thrust was about 35% higher than predicted. Now this could be partly due to the potassium nitrate grain size, but it also had some minor complications during assembly. What are those complications? Well, while squaring off the end of the casing, it came a little loose in the lathe and dented the side. I didn't think about it much at the time, but while inserting the grains, fuel grains, they got stuck where that dent was. So I ended up just ramming it with a PVC pipe since it was getting late and I wanted to test this thing. The fuel itself is quite brittle, noticeably more so than the sorbitol-based fuel I made on the first test, and I'm guessing it fractured it. This would bump up the peak can and lead to some higher pressures for sure. If you have any other ideas, I'd be more than happy to hear them though.